This one here. Now you see that just we have selected 1 to the 1 to not 0 to, right? 1 to 10th, 1 to 10th rows and all columns. So see here, running. So all columns are here, all columns, and 1 to 10th means what? 10 minus 1, this is 9. 1, it starts from 1, like that. So in that way, we can slice. If we have a data set, the data set can be, say, a split, or a slice of the data set can be extracted using this ILOC function. Because this ILOC function is very essential when we break the data set for training and testing. Then we have some options here that see here that if whenever we execute f.column, that ensures all the columns of the data sets. So see here, this one we're executing. Oh, I don't know whether what I done. So copy, bring this one. So if we execute this one, then we can see all the columns. See here, how many? This one, this. So column name, because column names are important when we invoke or when we want to have a particular column, data of the particular column, right? So if we want to have, then this with this file we have to invoke this one. We are coming to that one, right? But the column names are very important. That's why that I have shown you here. Using this function, we can see all the columns. Now see here, if we want to, so already you have all the columns. Now if you want to see the columns, only the column, which one? This column, hours studied. See, hours study column is there, right? That column can be invoked. File name or the variable name where the whole data set is stored, dot the name of the column. So the name of the column is given here, right? This one. So now if you run, then we can see it. Let's see that only this column. We're looking only this column, right? And now here I have the same thing can be done by different syntax here. The same thing, we're doing the same thing, but the syntax is now different. This is same thing can be done. So now coming, if we want to select more than one columns from the file, how we can do that from the data set. So we can do like that. This one for multiple files, we try to understand. So multiple columns. For multiple columns, we can do like that. See here, whenever we have a multiple columns, we try to understand we must have double bracket here. That's a third bracket, and again we have a third bracket. In the first third bracket, we have to give the name of all the columns where we want to extract. Here we want to extract hours studied from a mid-sem and the total. You can see here the whole data set right here. We have which one? So we are interested in this column. The hours studied is there. Then which one? Then mid-sem. Then which one? Then total. So just we have mentioned here. So in that way, right? In that way, try to understand whenever it becomes more than one. If it is one, then that can be written like that. If our objective is to extract only one column, it can be written like that. But whenever our objective is to extract more than one columns, then it has to be written like that. See now. Okay. Again, different notation is there, but I'm not going to show that notation. Different kind of notations are there by which you can do the task. One of the way. So after that here we have, so now if we want to find the maximum out of a column, then how we can do? We have already method is available. The max, using the max method, we can find the maximum out of mid-sem. So see here in the mid-sem, you can see the values, right? We can directly execute the whole data set so that you can arrive here. We could F2. So now we run that in mid-sem. See here the mid-sem, right? This is the mid-sem. And we want to find the maximum value from this column. How can we can do? Simply here we can do that one already we have taken like this one. This we have written the file name dot mid-sem and dot max. Max is the method, right? If you call the method, then automatically you can find the maximum value, that is 29. See this column, 29 is the highest. Out of this column, 29 is the highest, the maximum value. Similarly, if we want to have the maximum value from this one, and using different notation already talked about, just telling you, because this column can be referred in two ways. One way is what? The file name dot the column name. And second way is what? Just file name, and then we can give the name of the column within third bracket, and the single quotation is here. So whenever the max same method we are calling, we'll get the same result here. See here 20 times. Now if we want to find the minimum, same thing, right? It's finding the minimum value. Just we need to add the method here. Simply that this minimum value is 20. The method is added here. The same thing, right? Then we're coming here. If we want to have certain kind of queries on that, means if certain kind want to have certain kind of condition, based on the condition, if you want to extract the values, then how we can do that is called queries on data. So queries on data can be like that. See here, queries on data. So here I have written queries on data. See the description initially shows rows where test grade greater than 80. So how we have written this one? We have written like that. Means we are going to see the test grade where the value of the test grade greater than 80. So see here that this F2 dot, this one, it means what? It represents the column. Which column? The test grade column. In test grade column, if there is some value greater than 80, that index will be assigned here. Then later we can see this one by say printing A only, right? So see here we are running this one, and now see A. See that you can see the whole columns here, all rows here. So test grade, here see the test grade, right? So we are interested to find the rows where the value of test grade is greater than 80. So see here the value of test grade here everywhere. This is 98, 88, 86, 87, 94, 93, 89 kind of thing, right? So we can keep queries like that. Okay. So now we have another query here. The query is like that. Here the query is this. If we keep like that, so it shows whole rows where test grade is maximum. The rows where the test grade is maximum, that one we want to. So the condition is written like that here. This f2.test grade equals to ft.test grade max. Okay, so it will find this column and then find the maximum value, and that column is assigned, that value is assigned here, and later using this one, the whole column, whole row is extracted, and which is assigned to a variable that is a. See here like that, a, that is, it will show only one value where the value of test grade is maximum. You see here the value of test grade is maximum where that is where there is 98. So in that way we can find the maximum value, right? Now coming here, so here I have. So here we are interested to show two columns based on certain conditions. So here how we can do that part? Simply we can do this part here. So here we are interested to see only two columns, and these are the hours study and test grade where the values of total is greater than 90. So that's what we have written here like that. F2 already we know. If we want to extract more than one columns, how to write. The notation is given like this. This is the notation. And then here this notation is associated with a condition that is F2 total greater than 90. So whenever we get, because it executes in this way, right, from left to right to left. So initially finds the total where the value is greater than 90, and for those rows, actually, it will show this column and this column, and that part will be assigned to a variable that is a. So already it is stored in a. So printing here now, if we run, then we can see here, see. So we were interested in only two things, this one and this one, right? Where the value of total is greater than 90, try to understand. And now we're coming here, we have something else here. We're going to find something else. So again, invoking here the file, because now we changed the name of the file here in the code, that's why just changing here, because in here I have the file name that is F2, but the codes which are written where just I have a file name that is F1. That's why I'm doing the small thing, nothing else. Now the file is now imported to F1. Same thing, right? Same file is imported to F1. And now just we are interested to see the index information. So it is like that. So it gives the information about the index. So already talk about index is creator, right? So see here already talked about these are the index. These are the index. These index are created automatically. So it starts from 0. Already we have seen in this data set we have 0 through 90, means 20, we have a 20 index, 0s to 90. So if you see here the output, it shows that it starts from 0 and stops at 20. It means what we can say up to or before 20, that is up to 19, right? 0 to 19. But its stop is 20 here. And its step size is what? 1. We didn't give any step size, right? If a step size is not given, then by default it is 1. Now already here, whenever just I'm running this code, this file f1, see here, if nothing is given, then automatically one index is created, and that is here. And the value of the index is started from 0 to 19, means one less than of the total number of items. Now say if you are interested that we don't need to have this kind of index, right? We want to have an index that is the column of the data set. So one of the column you want to make the index. You don't want to have the automatic index here. But you try to understand, if you want to make the index from the data set, any one of the column, then those values should be discrete. Common values should not be there. So we can make a column as an index where the values are discrete. So discrete in the sense values are different, not common values. So which one we can do? See here, this one, right? These values are different, right? So these are not considered actually. These are not considered. These are what? Missing values. These missing values are not considered. So see, if you see carefully, these values are different. So for our study, we are having all different values. So we can make this one as index. If you are interested like that, then we can run simply this one, right? See, the code is here. This is the function. See here, just running. Simply just we made this one. F1 means F1 from the file dot set index, which one now I was studying. But one thing you should note here, that these columns will have different values. Exactly, we're having different values, right? Now this file, the file which is generated now, that is stored in this variable, that is f11. So now if you see f11, the value is this. You see the index is changed now. Now this one becomes index, right? Index is changed. But keep in mind here, the variable f1 means the file f1 and file f11, they are different. In f1, the thing is not changed. So you can see in f1 also, see here, so f1, there is no change, still is there. Because the changes, whatever we made here, that is assigned to f11, right? Now if we want to change this change, we want to do in the F1, then how we can write the code? Simply we can write the code like this. We want to change here only. So if we want to change here only, then it should written like that. No, it's not. Possibly it's not. Sorry. Yeah, then here, if we do like that, no, not here, then we don't need to assign any value possibly here like that. Coming. So if we do here only, if it is not assigned, then automatically variable possibility assigned to F1. Okay. So automatically assigned now, because now this part is not assigned to any variable. So we did some kind of operation here and then automatically saving F1 actually, right? So you can see F1 here now, F1. F1 is like that, right? No. This should be no. It like that, okay? So we have to assign to somewhere else. Means this effect doesn't affect here in F11. Then if we want to have, I think then F1 can be defined like that. Looking. If we define like that, then it's possible. Possibly looking. Doing this one looking. Yeah. Now changes is there itself. In F1 the changes is there now. So now in F1 we have changed. Now if you want to restore, right? Again, we want to make the index here. We don't want to make the index study hours studied. We want to restore. How we can restore? Simply we can restore this one by this one. Or again one thing I'm doing. the thing, whatever I have done here, the same thing can be done. The same thing can be done by writing this code. See here. By writing this code, we can do the same thing right here. It doesn't work. I don't know why. Looking. Run now. Already file is stored as it is. Now we can do this one. Possibly it will work now. So here we have, see this one now. It will be working possibly. Yeah, working now. So now see F1. Yes, see that now this one assigned. This index is assigned as say hours studied. The same thing we can done using this one, right? In place true means what? We set the index, this hours studied, and in place true means we are making index as hours studied, right? So now if we want to restore, then how we can do? Simply we can restore it by this one. We can restore it by this one. See, simply we can do. I'm showing these operations because these operations are required. Many operations required in say missing value handling, and then say this one data visualization. So whenever I run, then automatically it now in place true. Which one? Reset this one index. Whenever we execute this code, then automatically this index is reset or restored in F1. So now you see F1, then it is restored now like that. Now one more function is here. So see here the function and the description is written here. What is the function of that? It provides a data type of the different attributes because we're having different attributes, right? So if you execute this code, then you can find what are the types of the data which are stored in the file. So here we have info. It is talking about the data type of the values which are stored. So we have this one, this hours studies, the data type is a float. Test grade data type is float. And here midsem that is int, mid-nsem this is int, total this is int, and grade is object here like that. Now we have one more here, and then see here. So already we discussed about the data exploration. In data exploration, we have seen different kind of statistical measure. And if the statistical measure are like that, then what can be the conclusions we have seen, right? So now all those things can be seen by a single code only, a single function that is described. So see how, so see the description is what? Describes, generates the summary statistics of dataset F1. So now we are going to execute
Hi,
this.
sir.
Hello? Somebody is talking. I mean, hello. Yeah, this one. See here. So now if we execute this one, then you can see whole statistics of the data set right here. So what is statistics here? The count, means this hours studied. How many times are there? Two missing values are there, right? Total number of observations in the data set, we are having 20, but two missing values are there. That's why the count becomes 18. And in this case, three missing values are there. That's why this is 17. And here all values are there. That's why the count is 20. And here the count is again 20. And here the count is again 20. And if you find the mean value, the mean value 10.444 like that. These are the mean values, right? These are the mean values. And again, try to understand as we're having some missing values. That's why when we count the mean, then those values are ignored actually, right? Those values are ignored. And this is the standard deviation. And the minimum value is this. And the 25% value is this. 50% value is this. 70% value is this. 75% value is this. And the maximum is this, right? From the maximum, you can calculate half, kind of things, right? These are the statistics actually, right? So whenever you execute describe, then you can understand the statistics summary of different attributes of the data set. So by using only single function, we can do. So it's a kind of data exploration, right? So you can understand the type of the behavior of the data here. Now, if you want to find individually the mean, median, variance, and standard deviation, already we have seen in the NumPy library, we are having the statistical measures. A different kind of functions are there. So now we are going to use those functions. We are going to use mean, median, var, and standard deviation. So as we are going to use which one now, NumPy, that's why we have to invoke the module NumPy. How we can find invoke? Here is written, so I'm just copying only to import this one. So now we can import, see here. So we imported here, this NumPy is imported as NP. So whenever we write NP, it implies that it's NumPy. So now if you want to find the mean of only one column that is a mean same, then the code is like that. Or you can say the function is like that. Using this function, right, we have np dot mean. Whose mean? Mean of this attribute, mean of this column, mean of this column. Already we know how we can denote a column, right? Mean of this column. So now we can execute like this one. So this is the mean value. This is the mean value of midsame, right? So you can see here the midsame also mean value 26.15, and here also 26.15. So we are doing now here, we have done using the pandas, right? And we have a function that will describe the same task we are doing here using the NumPy. So we have another one here that we can do. Which one? We can find the median now. So simply you can find median because in data exploration we had all those terms, right? So now we can find median of which one? Median of this midsame. You see the median of midsame here. The median is not here. So similarly, we can do which one? Variance we can find of the same column. See here, same thing we are doing. You see the same thing we're doing, right? So, and one thing I'm adding here, the same thing can be done in different ways, right? You can change the way of writing. So then you'll get the same values. So already we have seen how to find this mean, median, and variance kind of thing. Now we're coming here. So we are coming to handle the missing values. How we can handle the missing values? Again, I'm showing once more the whole data set here. The data set is stored in F1. So see here where the missing values are there or not. Yes, some missing values are there, right? So this is here missing value, here missing value, here like that, right? These missing values are here. But you try to understand, as we are having very small database, that's why we can visualize it, right? By looking the entries. But you try to understand when size of the database is very huge, a million and million data would be there, then it's very difficult to find, right? How many missing values are there. And how we can handle those missing values? Initially, you have to find missing values are there or not. So here we have one code, or you can say the function, this function, and this, what is the objective of this function? This function shows Boolean data frame and shows true for null value. Wherever there is null value, and for that one it shows a Boolean value that is true. So coming, so just we are running this code now. F1.isNull means is there any null values are there or not? If there is any null value, for that one it extracts and it produces true. So see here this one, the whole data set, right? So if you see serially one by one here, if you see here true, here true. It means what? Here we have a missing values. Here we have a missing value. Here we have a missing values. Like that we are having missing values. Now the thing is that as the data set size is very small, that's why it's possible to see here. But if it is very big, then how we can do? This kind of strategy will not work. Then we have to see individually column wise and how many are there. If there is a kind of summary, then it becomes very easier to handle the missing values. And for that, we're having here the code here. So by this code, we are trying to find out, see here. So see this code here, let me, yeah. So now see, now we are interested to see whether there is any null value with this column or not. If there is any kind of null value is there, then you extract the rows. That's why we have written this one, F1 here extra, right? F1 here extra means we are trying to find out the rows. So see here, whenever I click here, you can see, yeah, that in here in our study, there are two, please don't talk. So there are two null values and the rows numbers are 20 and 15. In that we can find. But again, what we can do, we can, if we omit this one, looking what happens, right? If one is omitting from here. So if we omit this one, whether it runs or not. Yeah, it runs. But
Your
in this,
sound is not clear.
hello, sound is not clear.
Sound is not
Okay,
clear.
fine, 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 fine. Okay, so whenever we discard this one, then we'll get this kind of output. So whenever we can get this kind of output, then it's very difficult to find out the missing values. That's why we had this kind of code, right? So whenever we run this code, then we can find that in row number 2 and row number 15, there are two missing values, these and these, right? So now we have to find the missing values for all the columns. How many we're having? One, see here, 1, 2, 3, 4, 5, and 6, right? So now finding, so already for one, we have seen for our study, we're having some missing values. So coming to the second row, second column here, same thing we're doing, and we are finding whether some missing values are there or not. Yes, here, oh, also we are having some missing values. Three missing values are here, right? Now we're taking the third column and looking whether some missing values or not. So here, no missing values. See here, no missing values. That's why there is no rows. Coming here now, and same looking, is there any missing value or not? No missing values are there, right? Still, so good. So taking total and grade together, right? Together, one by one doing so that you can understand. Here, this. No missing values here. No rows are there. It means what? No missing values are there here like that. So here. So after executing all those here, which one? After here to here, after here to here means after executing all the columns, we have seen that in two columns we're having certain kind of missing values. Now, how we can handle the missing values? Already talked about the missing values. You can give some values there. You can give mean, mode. You can give a zero there. You can apply some algorithms and you can find out some values, and their values can be given. So in that, now the questions how we can do those things in Python. So see here, we have a small code here. It's a function. It's a function, and in this function, whenever we write like that, then it replaces all the missing values by zero. So see here, we are executing this one, right? So f1.fill now means you fill all the values where we are having now values, fill all those things by zero. Fill all those things by zero. So we are running this one right here. And whichever we stored, that is stored in a variable, that is f2. So now looking f2 now. See f2. F2 is a data set, right? In data set here we had missing values. Here we had missing values. Fine. Now here we have zero because here fill up means we filled up all the missing values by zero. So whenever we write this code, it means what? All the missing values would be replaced by zero. But now you may not be interested to replace those things by zero. You may be interested by something else. Now say for the time instance, we are interested to replace all the missing values by the mean of the column. By the mean of the column. So coming here, and again you try to understand, if you find the mean now, right now these values would be counted as zero. This value would be counted as zero, right? So if we compare the mean and earlier mean, then we can see that there would be a bit of deviation. So those things should not be there. When we want to use the mean, then those values should not be there. So then, or it is your way how we want to use the mean. That is totally depends on you. See here we have seen already, this part is already we have seen. Now we want to find the mean, but we don't want to find the mean from here. We don't want to find the mean from here because if you find the mean from here, then it becomes less. You can check it out. See here that I'm just running the code so that you can see. So for the mean, the code is this. So for the mean, the code is this, right? So now the file, the data set is stored in F2. Just we're going to change only the F2 here. So now see this one. And now F1 is changed by F2 because the data set whichever we have generated, that one is stored in F2 now. So if you write F2, then you can find mean of our study. Now here, it becomes a bit lesser than earlier. And the value of A is how much? See here, it becomes 9.4, but earlier it was 10 point something. Because now these zero values are counted here. So whenever zero values would be counted, then automatically mean would be, say, the value of the mean would be dropped. So we are not going to use this one. We are going to use from that mean. So how we can do? I'm just running the code again, simply because if I call the file like that, then automatically again we can call the initial file in F1, this initial file of dataset. You try to understand, we're interchanging the terms, but they are a bit different, file and dataset. But we are interchanging. Sometimes we're telling file, sometimes we're telling dataset. So here, these are the null values. So from here, we can find the mean now. So whenever we calculate mean, these things are not calculated, right? So already we know how to calculate the mean. So here we are calculating the mean of hours studied. So the mean value is stored here now to A now. It is stored to A now. We calculated the mean value and it is stored to A. But if you like to see the value of A, then we can print it out. And then it becomes 10.444 now. So that is the mean value of which one? Mean value of this one. Now we want to calculate the mean value of test grade, because again there are some missing values. So doing that one, simply we have a code here, small function. So doing this one and running this one now. So this mean is stored now B, then you can see B. So now we calculated two mean, one mean is stored in A, another mean is stored in B. Now both we are going to replace the null values by this mean. So how we can write? Simply we can write the code here. So we have the code here for that. And this is the code. So here we have the code where we have used both at a time. We want to replace the null values by both means, for this column by A, for this column by B, or again you can do individually, there is no problem. So if you run this one, then now these missing values are replaced by A. This missing value, you try to understand, we have written what F1 dot fill na. That I'm just discussing like that. If I discuss all the functions like that and I cannot finish it up, right? And then half of the, whichever I have decided and made the materials, 1/3 of the material I cannot complete. Some of the things you have to do, just I'm showing you. So if I explain each and everything, it's not possible to cover up. So here we have a F1 and a fill now, means we're going to fill up now, which one? This column, the missing values of this column by A, and already we have calculated A is what? A is the mean of that column. Similarly, if you want to use certain kind of machine learning algorithms to treat the class imbalance, to treat the missing values, so similarly, you can create the value here. And then by calling these functions, you can replace the value in that way. And here we have a test grade, the missing values of test grades. Missing value of test grades are replaced by B. So simply we have done and executed. Now see the file F2. You can see all the changes came here. So all the changes came here, right? So we had a missing values here. The missing value is now replaced by mean, right? Similarly, we had here, I think, this is changed by this mean. Similarly, here, this one, 73, this one, 70, here, 73.58. Yeah, here we had one missing values, and the missing value is replaced by B here. Similarly, all the values are replaced, means all the missing values are replaced by the mean of this column, right? So here we have seen how we can handle the missing values if we have. So similarly, you can use, already talked about different algorithms to calculate, and then those values can be used in the missing values. So this part is gone, I think, right? This part has gone. Now, not gone, right? So we just imputed the data. We just imputed the data. And missing value handling can be done also by removing the rows and columns, right? How we can do rows and columns? We can do rows and columns, removing rows and columns by drop now. See here, the drop now we have. So now if you see F2, now we're not interested in F2 because in F2 already the missing values are handled. So we have to see F1 here. So looking the F1, so you try to understand, just again, just to make a summary here. Here we have handled the missing values by data imputations. Now we are going to do the same thing by deletion, right? So initially we have to see the file F1 looking, yeah, still in F1 we are having the missing values, because the values whichever change, that one is stored in F2. So in F1 we have all those missing values. So if you want to drop the rows and columns, then simply we have a function here that is called dropna. Dropna means what? Removes the rows having missing values. So whenever we have a missing values, that is represented by MAN in Python. So all the values of MAN, the rows which are holding the values N,
ডিজিটাল নাম দেখতে হবে ডিজিটাল ভালো
any issue. So here we can drop the rows simply by drop na. So coming here, so already we have seen here in this row we are having a missing value. In this row we are having missing value. In this row 3, and here 4, here 5. So we are having 5 rows where we are having missing values. So simply if we execute this code, then simply drops all the rows from the data set, and that data set is stored to F2 here, right? So dropna is the function for that one. So we are running now. So that the data set, or the refined data set which is generated, now that one is stored in F2, right? I have F2 here, just running F2. So see here, the rows which were having the missing values are all deleted. See here that row number 2 is not here because this one now is deleted. Now we have questions that we are not interested to delete the rows. We are interested to delete the columns. Now how we can delete? Using the same thing, right? Drop, not just we need to change. So just again, I'm telling here, we can pass some arguments. If x is equals to 0, it is talking about, we are talking about the rows. Whenever x is equals to 1 means we are talking about the columns. Not only here, in Python, whenever you are having axis kind of thing, rows and column or axis kind of thing, whenever x is equals to 0 means it is talking about rows, and x is equals to 1 means it is talking about the columns. So now showing the same functions using x is equals to 0. Same thing we are going to see here. See here we have to see the F1, because F1 we are having missing values. Yeah, in F1 we are having missing values. So we are going to do the same thing using some arguments, and that is x is equals to 0, and we want to store in F2. Same thing now, or no, F2 we are having already, right? So F3, I can give a different name so that you cannot have any confusion on that. So whenever it is 0, 0 means it is working on rows. So drops the values or drops the rows which are containing some missing values. So just executing this one, right? And now see F3, simply you can get it, right? The same thing here. We don't have 2. We don't have 2 here. 2 is deleted as we have given x is equal to 0. And by default, if you don't pass any values, by default, it deletes the rows. But as we are now interested to delete the columns, that one can be done very easily. That is dropna x is equals to 1. So see here. So again, we have to see which one, F1, because in F1 we are having missing values. So here we have a F1. So all missing values are here. So see here, in this column, we are having missing value. In this column, right? Similarly, in this column, we are having missing value. Now we are interested to delete this and this. So simply we can do here. So we have a drop now here, and that is x is equals to 1, means columns are going to be deleted. Now, say after deleting, the refined data set is stored in a variable that is F4. So here we have now. So we are running now, looking F4 here. So there is F4, see here the columns are deleted. Simply we can do, if you're having the corrupted data in a data set, if you want to delete some of the columns, then simply you can delete the columns, right? Fine. No, not here. As we don't have a missing value, that's why we can do it. And then that one can be done another way. I'm coming to that one. So whenever we have a missing value, we can do like that. If we are interested in dropping the columns, then we can do like that. So already we have seen how to handle the missing values if you want to create, or if you want to replace, means if you want to delete. And one more operation which is very important, you can see one function, that is what that is talking about the replace. Simply by writing the replace, you can replace the some value with some another value. If we are interested to replace all the occurrences of 81 by 100 in a file that is f1, then simply if you write this, then it will happen. So see here. So now again f1 we have to see in how many places we're having 81 so that it can be more sanguine. That is the code is working. So see here f1. So here we have 81. Here we have 81. Like that we can have number of 81, right? Here we have 81. Now say we are interested to replace 81 with some values. Simply that one can be done here. The code is very simple here. Yes, we are interested to replace 81 by 100. So execute this one simply, right? So all occurrences of which one? It happens in which data set? It happens in F1 because I didn't store in somewhere else. So if you see that 81 it is replaced by 100, 81 it is replaced by 100, 81 it is replaced by 100, like that. Okay, so replacement is done here. Now we come in here. But we can sort some values, sort the values. So if you want to sort the values, I'm showing, then after sorting, we're coming to data visualization part. So if we are interested to sort the values, right? See initially the F1. So which one is the here? This is the F1. So F1 is here, right? This is the data set. This is the data set. And now in F1, we are interested to sort the values by which one? By midsem. And try to understand if we don't add any argument here, then generally the value is sorted in ascending order. So see here, if you run this code, then you can see here in F1. So which one sorted? Midsem. See here the midsem, it is in ascending order. And the midsem, see here, 20 comes here, then 21, 21, 23, 24, 25, 26 kind of thing. So if you don't write anything, then automatically it comes in ascending order, right? But you have to give by which one you want to sort the columns. So here the column name is by equals to midsem. Similarly, what we can do if we are interested to make it in descending order, then we have to execute this one. See here. So then what we need to do, see here simply, here we have written F1, sort values by which one? By midsem again. But here ascending order equals to false. Ascending equals to false because by default it comes in ascending order. So if we want to have a descending order, then we have to make like that. Ascending equals to false. If we execute, then we can see, and now midsem values, right? So now midsem values are arranged in descending order. So 29 is here, 29 is here, 29 is here, 29 is here, like that. Now, one more thing is here. So now, if we want to sort a values by sort a data set by two values, then what will happen? See here. So now we want to sort data set F1 by two values, and the values are total and which one midsem. So we try to understand as the total comes first. That's why the first priority will be given to total. If there is any kind of tie in total in say ascending order or descending order, then that one would be sorted out by midsem. Fine. So now here we are interested to sort the values. Which value? We are sort the total by ascending order because it didn't mention anything here. So by default it takes ascending order. So we are running this one. So here now this is the data set, right? Initially in the total you see the ascending order, the total 72. Here we have a 76, 76, 276, right? Now whenever there is a tie, that one would be sorted out by midsem. Right here on the midsem, the 28 comes here and 29 comes here. Like that, you can see the whole data set. Right? So one data set also can be sorted out by two columns, right? So we have seen here how to handle the missing values. Now we are going to talk about the data visualization, how to do the data visualization part. So we're coming here. So in data visualization part, we have to make the graphs and the bars, and already talked about for graphs. For two-dimensional plottings, we have a library function that is called Matplotlib. So we have to invoke that one. This is matplotlib.pyplot. Right? So module name is a pyplot, and now this pyplot is, this whole module is, this pyplot is invoked as PLT, aliasing is given PLT. So whenever we write PLT, then automatically the whole module comes. So we need to write only the PLT with some function. So see here, we're coming to make a bar chart initially. That's a bar chart. So I'm taking the whole code, then I'll explain one by one, right? So taking the whole code here, now going to explain for one bar chart. I'm going to explain all the things. So we are interested to make a bar chart for a data set F1 by taking two values. The value is this is our studied and this is test graph. So we are interested to make a bar chart between two values that are hours studied and the test grades. Fine. So these things should be, and now which one, what we have done here, all the values means the value of this hours study is assigned to X, and this value, this column value is assigned to Y variable. So we have here two variables X and Y. Those variables are holding the values of hours studied and test grades. So these are the comments only. So the comments are deleted. Comments are deleted because these hours studies and test graphs all are coming from this file. That's why file is invoked once again here. Fine. And now here we have a code for the graph. Simply here we need to call PLT. PLT means there is pie plot here. Now we're going to do, and dot bar means we are interested to make a bar chart, and the bar chart is represented by dot bar, and here we need to give the value of x-axis, and here we need to value of y-axis, right? So here we have taken those values in x and y, but we try to understand directly. Also we can do the same task by putting directly the values here. So in the second iteration we're going to do the same part. Then here we have written here level equals to marks. So if we want to make certain kind of legend in the graph, certain kind of legend, I'm going to show you, right? So if we want to make certain kind of legend, then we have to label it as mark. And against this, we have to make a code here. We have to make a function here that is plt.legend. Only then it will be working. And after that, here we have a graph, a color, which color generally we want. If it is red, then red. If it is green, then green. So here, just I have written here red, so that the graph, what we get, the color would be red. So now, deleting this one. Now here, what is that? It is talking about what we are going to, by which value we are going to label the x-axis. And for that one, the function is like that, plt.xlabel, and here the argument, and this argument is the name of the label what we want to have with the x-axis. Similarly, if we want to have certain kind of label with y-axis, then that name has to be given here. Fine. And now if we want to have certain kind of title for the bar chart, the title has to be given here. That is plt.title, and here we have the argument. This argument is talking about what would be the title name of the bar chart. So already we talked about all the things. Now I'm deleting all the comments from here. Comments from here, and this legend is especially it is to establish the legend. So if we want to establish the legend in the graph, then we must have this one, and correspondingly we must have this one. So going to see one by one by deleting all those things, then what will happen we can see. So now we have deleted all the columns, just we have here the code. So we are running this one. So if you run this one, see here the bar chart is created. So this is the bar chart now. So that already we already talked about the title of the bar chart will be NIT signature, then the NIT signature, and here the X level our studied. So that's our studied, and this level is what? Y is test grade and a test grade. And now according to the values of X and Y, this chart is created. This bar chart is, or bar graph is created. And we have given here legend. See here legend is given here. So this is called actually legend, right? So if we omit this legend, then this part we will not see in the graph. Just doing that one. See here, just I'm deleting from here this one. Then what will happen? So I'm already deleted. So now again I'm running the code, so looking what we'll get. Yeah, we got the chart, right? But that legend is not here. Why? Because we omitted this one, deleted this one. So even if we can keep this one here. So this, oh no, here, sorry. So I have to make another one. So here I have a legend here. No. So copy this legend and put in here only. So legend is here. Now say we don't give this one. Label equal to marks is not given here, and try to make the legend, whether the legend is created or not. Looking it is created or not. So if we execute, So legend is not created. You try to understand whenever you want to make the legend, we can have a legend here, and correspondingly we must have here one argument. Only then we can create. Similarly, if we don't need to have the title, then we can omit it. So omit the title from here. So deleting this one. So now run. You will not get the title here. Similarly, if you don't want to have this X labeling, then you can omit it, and Y labeling, you can omit it. Like that, actually, we can create the bar graph. Simply, if we have Matplotlib library function, then we can do, or we can make the bar graph very simply, right? So already one thing I told you, instead of X and Y, directly we can give the values here, right? But you make a habit to give here X and Y so that you can have in your mind that, so whenever we are putting the values, these values are X, and whenever we are putting the values, these values are Y. But if you don't give, still it will be working. But how? Simply we are putting the whole value here, looking whether working or not. Should be working? Because simply we are keeping the values there. Simply the values are keeping there. We need to what? We need to delete both of them. So now looking whether the graph is created or not. Yeah, the graph is created. So simply we cannot assign, even if we are not assigning this value to X and this value to Y, directly we can keep the values here. In that way, bar chart can be created. Now we are coming the histogram. Already talked about the histogram, right? One of the histogram we're going to create, then I'll explain all the things one by one, right? So here the histogram is created for which one? The histogram is created for test grades. And we are going to find the ranges, means how many test grades are within 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 60, means range is defined here. So you can give the different ranges here. If you give different ranges, then it will create a different graph, right? So here, the range, whichever I have created here, that is the 10. So now we're going to see whether it is working or not. See, now we're going to make the histogram. It's a bit different than the bar graph. Then you can understand coming. So now we are interested in bar graph. So here we have, so we have taken this test grade, this data frame we have taken to test only now, because already we know by this one we can take, already we have seen, and this is our comment only for which one we have created the bins, the ranges of 10 will be deleted. Now see here the number of things are here, right? So in the histogram we can keep the values here, and if you want to make different ranges, that range we can create like that, and that's called bin. So that bin, or it can be any kind of variable, right? That variable can be given here. Then histogram type, which type of histogram do you want to have? So here for initially, we want to have bar type of histogram. So we have written here bar. And this is R width. Width means that is the width of the bar. That's the width of the bar, means how much percentage would be the width of the bar. Here 0.7 means the width of the bar would be 70%. We'll change, then you can understand. So color is green. Again, we have, you say label equals to marks. We have a legend here. That's why we have done. And these are what? These are the comments. The comment section is deleted now. Comment section is deleted. Deleting the comment section. So it is deleted. So now if we run it, then you can see the histogram. So this is the histogram, right? So if we have this kind of value, I'm just putting it out, the value, the test is there. So writing the test, then it is better to understand. So test values, this is the test values, right? So we are having this kind of values. And we want to see how many values are in between 40 to 50. So 40 to 50, how many values we're having? We are having a 4. So we're looking here, 4 values are there. Similarly, how many values are in between 50 to 60? That is 1. 1 is given here. So if you see here, then you can understand from here, right? So you try to understand histogram is created for the big database. Here we have only the 20 entries, but try to understand we can have million and million entries. In that cases, if you want to have an easy understanding how many items are there in what range, then we need to create a histogram. So I'll talk about this one, right? I'm changing this one, and then you can see So already I told you this is the width of the bar. And here I have written 0.7 means 70% width is there. So now it is changing to 90%. See here. So then you can see the width of the. So now it is created. Now the width. This is the width. Width is increased now, right? So it is talking about the width. Now we can create different kinds of. Here we have created a histogram of bar type, but we can create it in the different types. The types are written here. The his type can be, so bar is stacked. It's a kind of same thing. It can be step. It can be step filled. So making a step. If you make a step in many books, you can see the step size of histogram. Generally, it is given like that. So just we're changing the bar here and making this a step here. So if you make step and run, then you see that what is how the output becomes. There you are. Now this is a kind of the bar graph, histogram. So in image processing, you can see in most of the cases the histogram is like that, right? So now if you want to fill it, then simply we need to change the parameter here. The step field. So we can give here a step field simply. So here we can give a step field. So field, the step is filled by green color. So you can change the color here by writing red only, right? So madam, you tell me one thing, because if I show all the things today, because we have a bar, how to remove the outliers using say a box plot. If we do, then we have to do only the practical today. We cannot do theoretical part. So should I do?
Okay, sir. Carry on, sir. No problem. It's
No
good.
problem.
No problem, sir.
So you give me 1 to 2 minutes because I'm talking continuously actually.
Yes, sir. No problem. No problem. You can take a break. For...
1 to 2 minutes only, right?
Sure, 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 sir. No problem.
Hello, I'm coming back. So I just came back here. So am I visible now?
Yes, sir. You are visible, sir.
Yeah. So already we have made one histogram here, right? So we found here the different ranges, how many items are there. So when we discussed about the histogram, one thing we discussed that if we have a data set, whether the data set is class imbalanced or is balanced, if we see the level of the data, if we can represent the level of the data by say histogram, then we can understand whether the data set is balanced or imbalanced data set. So already with me in this part, you try to understand in this part, I'm showing you the part here. So in this part, I have a data set that is iris data set. You can see here iris data set available here. Iris data set is available. So now I am interested to see the class level of iris data set using a histogram. So looking here, so the path is same, just the data set name is different, right? So here, So I'm running this code so that I can install the whole file, import the whole file to a variable that is f1. So putting that one here. So in f1, so I had a whole data set here that is iris1. So running this one, and now the data set is available in f1. So now we can see the data set f1. So here we have the data set already talked about. The top five rows we can see, and bottom 5 rows we can see by default. And if you want to see, then we have a different code already we executed yesterday. So now we want to see different kind of columns, right? So columns coming here, the columns can be seen by this code or this function. We see how many columns are here, the sepal length, sepal width, petal length, petal width, and then where the space is, right? Here already we can see, right? So now we are interested to see how many classes, because this is the class. This is a class. This is a supervised learning. It's a data set of super level data set. These classes are associated with each of the observations. For example, with this observation, the class which is associated, that is the iris setosa. And here similarly here iris serosa. And here if we see 145, there is iris virginica. So already talked about, this is the 3-class classification problem. So 3 classes are there. Now we are interested because here only we have 150 rows. That's why if we count, then it is possible. But if the size is very big, then it's really very difficult to find out how many patterns are there of which classes is really difficult. But you try to understand the class is represented by this species, right? So now we are interested to make a histogram of these. So if we make the histogram of this, then automatically we can understand how many classes or which classes are having how many patterns or how many observations. So here we have the code for that. Yes, I'm going to explain all the things, but before that, just putting here. So already this one is invoked. Already it is imported, but still we have written here. If you omit, there is no problem because it is already imported. Matplotlib, fine. So now we want to make the histogram of which one? F1 dot species. Is want to find the different classes. How many are there? And the histogram type is bar, width is 0.7. Already we are experienced with all those things. Now we are looking. Yeah, see here. Now you can see the number of classes. The iris serosa, here this is 50. The iris versicolor, this is 50. Iris virginica, this is also 50. So from this histogram, we can understand the database is balanced here. So if we can understand the data set is balanced, then we don't need to use any kind of treatment of imbalanced data set, because whenever the data set becomes imbalanced, we need to have certain kind of treatment, right? So now we're going to see another kind of one more data set where that is the imbalance. So we have another kind of data set here that is a thyroid data set. Here the thyroid data set is stored here. There is a thyroid data set in this part, right? And there is imbalance in nature. So we're going to see in the histogram. So here this file can be imported like this, and it is imported to F1 by this code. Already now this thyroid dataset is now imported to variable F1. And now we are interested to make the histogram for this F1 with classes, class labels, not for all the dataset, for the class labels. So see here that here you can see the class label is represented by class CL only small s. Because when it was a class, I was getting some kind of error. That's why I made it class only. So if you run this one, see here, we have this one now. Now we histogram for which one? F1 dot class. F1 dot class, right? We want to. Or before that, you can see the whole data set, right? So that you can have an idea of different attributes of this data set. Because now the data set is stored in variable F1. So now we can see F1. So this is the data set. So how many attributes are here? 1, 2, 3, 4, 5, 6 kind of thing here. And the class name is represented by class, right? So if we want to import this one, then it can be imported by f1.class. So we want to make a histogram of f1.class. So we are making now the histogram of this one. and all are the usual functions already we have discussed. So see here that we have a histogram f1.class and all are similar. So now we're going to make the histogram here. So see the histograms. We have it's a two class problem. That's why we're having 2 bar only. And in one bar we're looking more than 350. And in another bar we're looking only 50. So this database is a database which is imbalanced in nature. So whenever if we analyze it by histogram, then we can understand whether the database is a balance or imbalance. If the database is imbalanced, then treatment of imbalanced data set we have to apply here. Otherwise, we will not get good result. When we talk about treatment of imbalanced data set, then we'll see if the data set is imbalanced, if we don't do any kind of treatment, how much accuracy we are getting, and if we do certain kind of treatment of class imbalance problem, then how much accuracy we're going to get. We are having all those codes, right? So it's still how many? I have done hardly 2 or 3, how many? 6 page, but I have a 55-page code here, 53-page code. So we're going to do that. How many we can do? So looking on that. So now if we can make a pie chart, right? So pie chart, how we can make? Well, the notations are a bit different. Just I'm interested to make. I'm very much interested to make this one because number of things are there, right? So to point out, so making a pie chart here. So when we made a pie chart using say Python, see here, we made a slice, and this slice is nothing. It's a list, right? As a list. Now I want to make a pie chart of the share of different department, and I have assumed that the subjects what we have, if I find the percentage y, then the science subject will have an impact of 20%. Departmental subject can have an impact of 50%. Other departments is 20%, and humanity is 10%. In that way, I made it, right? So I made it. I made a list. So but in this list, I have a different kind of CS here. The summation should be 100%, right? So the summation is 100 here. And the name of the first one is science, second one is like that, like that, like that. And I want to assign different color of the different segments, different slices. So green is given for science, red is for department, blue is for this, yellow for this. Now, if we want to make the pie chart, then I need to write this code only, plt.py. Then for which values? For these values I want to make, right? And these values are stored in this variable. So this variable is given here. There's a slice. Then comma color. This is which colors I want to have. I want to have a different colors, and those colors are stored in cols. Yeah, cols. So cols are here. See here in cols, 4 colors are assigned, right? The cols are here. And labels is what? Say components. And in the component, labels, and how we can label the pie slices. And in components, we have a science department, other department, humanity, right? And start angle means how we can start, whether we start from say 12 o'clock or we start from 3 o'clock or 6 o'clock. It can be decided by these values, right? And here we have a explode. Explode means, do you want to make outside any of the slice? Initially, you don't want to keep any slice outside of the pie chart. That's why I've given 0, 0, 0 kind of thing. Shadow, yes, true. If shadow is there, then the visibility is good. And then this, by this one, we can represent the percentage on different component. So for this one, for the first percentile dot one, it means that the percentile which can be shown on the component, it would be 1 decimal. That's why this is 0.1f. And here we have a 2 percentile. It means that we want to show 1 percentile. This is the basic of Python, right? And the title is this. Legend would be there. Just legend I kept. I don't know legend would be there or not. Possibly it should be discarded. And then this is what this is what, yeah, labels are there, right? Yeah, yes. Legend would not, sorry. I should delete it from here. No. Wait. Legend. Label is there, so legend must be there. Then we are showing the plot here. So now going to see, and then we'll change the parameters. So now see this one. So this is the pie chart, right? Whenever we have the 90 means it starts from 12. It starts generally from humanity, right? From backside. So if we make it say here, see here 0 degree, then you can see it start from 3 o'clock. Yeah, from 3 o'clock it starts. From 3 o'clock, humanities come here. So changing the position only, right? By this starting you can do. And now in explode, if we change the explode, then how it looks. Look here. So none of the slice is outside of the pie. So now if we want to have outside of the pie, so it looks very bad, this legend, right? So I'm just omitting the legend from here. So looking, yeah, that part is out now. And now if none of the slice is outside of the pie, so if one of the slice, if we want to make outside of the pie, so the first one is due to one science, for an example, right? So this is 0.2. So if we do like that, you see here, the science comes out here. When you see here, the science comes out. And this percentage is represented by this one, by this one actually, right? Already talked about the percentage will be shown by 1 decimal point. That's what we have given 0.1f. And after that, we'll have a 1 percentile or the percentage. That's what we have 2 percentile here. In that way, actually, we can create the pie plot. Okay. So after pie plot, we are having here one more thing, that is a line plot. I'm not going to make the line plot. Simply we can do right line plot, but just I have shown you. So in that way it can be created, right? It's a kind of boost. So just the people, those who don't know, many of you know better than me, right? So many of you don't know how to handle Python. So simply you can see, just if you put the function there, then simply we can make different kind of plots, different kind of execution we can do. Now we are very much interested in which one, and a box plot, because using box plot we can understand, is there any outliers or not? If there are some outliers, how we can omit those outliers? That's the question now. So we're coming here to make the which one, to make the box plot. So we're going to analyze the box attribute wise. Then it's better. See here. So all the libraries are already imported, spun as PD, and this one matplot.pyplot already as PLT. So we don't need to invoke those things again. Just I need to already, I think in Iris is available in F1, looking whether F1 in Iris is available in F1 or not. So in F1, yeah, Iris is available, looking. No, Iris dataset is not available, but we're going to make the box plot for the Iris dataset. That's why, again, I'm importing the Iris dataset to a variable that is F1. So see here. So we have a F1 here. So we are running fine in F1. You can see we have now Iris dataset. Yeah, we have Iris dataset now. Now, how many columns, how many attributes we're having? 1, 2, 3, and 4. In box plot already we have seen that for each one we can make a box, and from the box we can analyze five statistics, and from those 5 statistics we can say whether some outliers are there or not, based on that attribute only. You try to understand, based on that attribute only. So coming now, so you can see the columns are already available, don't need to do. Now making the box plot for which one? For sepal length. Initially we have a sepal length here. So here we have a sepal length. So initially we're making the box plot for the sepal length, and we're going to show it by this one, right? So here now we have this box plot, right? So this is a minimum, this is a first quartile, this is second quartile, means a median, this is third quartile, and then this is maximum. So we are looking here, none of the value is lying outside of the maximum and outside of the minimum. So if we analyze the whole data set from the perspective of sepal length, then we can say there is no outlier. With respect to sepal length, only one attribute, right? So now we're coming with another attribute. So all the attributes are not working together. You try to understand using, say, box plot, we can analyze only one attribute or single attribute at a time, because during the discussion of the data visualizations, I told you it's a histogram, and this box plot can analyze only one attribute at a time. So whenever we want to analyze 2 attributes, then we'll have scattered plot, right? So only one attribute can be exercised, it can be executed, it can be analyzed using box plot. So here we have seen sepal length. Now we're finding this one. Which one? Sepal length. Well, sepal width. So in sepal width, going to make a box plot of that. Looking, yes, this is the box plot for this one, right? Okay, so now we're running here and plot is created, and here we're looking that one of the value below the minimum, so this is uncommon, so it can be outlier, right? And similarly outside of the maximum we are having 3 values. So now if we analyze the whole data set from the perspective of sepal length, sepal width, then we can say how many outliers are there. 4 outliers are there. If we analyze the whole data set by a single variable, single attribute, right? But you try to understand it is a multi-dimensional data set. Each observation is represented by 4 input variables and 1 output variables, right? But a box plot is especially to analyze a data set where we have only 1 input variables. But that's why we're doing one by one and looking at what is the drop. If time permits, then today I can show you. So now, so we analyze the sepal width now. So now we're coming, which one? The petal length. Using petal length, whether there is any outliers or not, we're just analyzing here. Sorry. We can run here. So we have a plot, right? See, this plot is like that, and median is here, right? So if the median is here, then what we can say? We can say most of the here concentrated towards this value, right? This is the median. This is the median, right? So no, here again it is clear that there is no outliers because no value beyond the minimum, beyond the maximum. Very good. Now looking the fourth one, the last one, that is a petal width. So here the petal width, petal width. So here we have a petal width. So by petal width, we're looking here. So in petal width, again, we don't have, right? So based on only one parameter, one variables, we are having certain kind of outliers. So which one? Sepal width. So now, based on only one parameter, you try to understand. So based on that parameter, which rows or which samples are treated as outliers, means whose values are beyond that and below that we need to find. And that one can be done simply. It is especially this filter 0 is specially designed for the box plot. And here we have a get data 1 looking. So from where we're trying to find out the outliers on the PLT box plot now, F1 sepal width. Already we have seen that in sepal width we are having some, with respect to sepal width, we are having certain kind of outliers. The outliers, those who are outside of the maximum, or that is called outside of the whiskers, the maximum, and below the minimum, that's below the whiskers. So outside of the whiskers can be found using filter 0, using this part, right? And then we are getting the values here. So the values which are with respect to sepal width, lying outside of maximum and outside of minimum, those values will come or will store. If we execute this one, those values will store in the outliers. So now running this one, right? So here we have a box plot here, because the box plot we have written, right? If you don't write the box plot, then simply the values will be assigned here, right? So we have the code, so I don't want to modify now. So now we have an outlier. Simply we store the outliers. Looking now, yeah, outliers. So now the sepal width, whose value is 44.2, 44.1, 4.4, 4.1, 4.2. These are outside of the maximum, and the value 2 only, that is below the minimum. So the value, the values or the sepal width, when the sepal width value becomes 2, then the sample becomes outliers according to this attribute only, right? When the value of the sepal width becomes 4.4, then again it becomes outlier. So we are having these outliers whose values are sepal width values are these. Now we need to find the patterns, right? Which patterns? Then we need to drop those patterns. Only then we can say outliers. Outliers are removed from the data set. Because now what's our objective? Because we got the outliers. So somehow those outliers should be removed from the data set. If we remove from the data set all those outliers, then it is a bit hope that now the data set is very good. Now the data set is very good, and if you run in a classifier, then the accuracy can be better, right? But it doesn't work in this data set. I'm just already I told you, but again I'll explain why actually. So now our objective is to which row is having this value, this value, this value, and this value, and then those rows have to be dropped from the data set. Simply that I have written here the code. Already we know the condition, right? Based on some query, we can find the index. So here that I have a code here. So simply just at a time, just at a one shot, I'm running. Just explaining you that all those things here you see already we have seen and we know that these are the values sepal width values. So I have written here f1 dot sepal width equals to 4.4 dot index. It means what? It means it finds the index of the rows for which the sepal value becomes 4.4, and that index is stored in I. And then by this code, what I'm doing, just I'm dropping that I from file f1. After dropping this f1, I'm storing that file into f2. Similarly, in f2, only one, you can say only one row is dropped. Only one outlier is dropped. Still, we are having 3, 1, 2, 3. So similarly, in f2, again, we're finding whose value is 4.2, and that index is again stored in I. And again, this index is a drop, and the value is stored in f3. Similarly here, because two outliers are dropped, now looking in and the value is stored in f3, and in from f3 we're looking whose sepal width equals to 4.1, and that index is assigned to I, and that I is again dropped from dataset f3, and that one is stored to f4 here. Similarly, for the last one from f4, whose sepal width value is 2, that index is stored in I, and that one is dropped. And finally, after dropping 4 outliers, the data set is stored in f5. So in f5, if you see the number of data set, then automatically it will reduce 4 in count, then f1. So now we are executing this one. So execution is done. So if you see the f2, then only one outlier is deleted. So see f2. So you can see 149 rows are there because one outlier is deleted. Now if we see f3, then 2 outlier is deleted. If we see which one, f4, 3 deleted. If see here, 2 deleted, f3, sorry, f4, 3 deleted, f5, then 4 deleted. See here. So now we have this data set, and this data set is according to which value? According to only the sepal width. Now this data set is out of outlier. But you try to understand this data set is consisting of 1, 2, 3, 4 input variables or input attributes. So whenever we want to characterize some of the observation as outlier, then the impact from all of the attributes should come in consideration. But you try to understand whenever we find the outliers using a box plot, then we are going to consider only the single variable or single attribute. So whenever we have a multi-dimensional data set, it's a multi-dimensional data set, we cannot find the outliers using the box plot. So if we have a single, that means one dimensional, means one input and one output. So in that case, this box plot will be working very good. But now looking whether this box plot is working or not, right? So initially the whole data set is stored where? In F1, right? So now we are running F1 and looking the accuracy. And then we'll be running which one? F5, because F5 is a data set where we have the data after outliers are removed. And outliers are removed subject to. Outliers are removed using the box plot. Then we'll compare the accuracy. And here, initially I have taken, still I didn't discuss with you, this I'm going to find the accuracy is using decision tree, because we are having decision tree. Those things will come very later. But now I'm not going to discuss the code, but I'm trying to just that the decision tree is now going to be used to find the performance. means after deleting the outliers, whether the accuracy is improved or not. So now you cannot understand, right, the code, but just you can see the accuracies only. So you are now interested in accuracies only, nothing more than that. So looking initially with the full data set, F1 data set, where we did not discard any of the outliers, right? So this is the code. The whole code will be discussed and you can understand gradually one by one. We'll do all the components possibly within 7 days. Not possible. I'm thinking so. So I'm looking how far can I complete. So this is the code for the decision tree and which is applied in the iris dataset. See here, iris dataset. And these things is now beyond of the scope. We'll discuss later. But here, what we have done, 70% of the data is used for training and 30% of data is used for testing in F1 dataset, where we did not do any kind of deletion. We did not delete the outliers. Now we are interested to see the accuracy. How much is the accuracy? Looking, coming, executing, looking. It will take time. Not coming. Why? Yeah, just it has come now. So the accuracy, we are not interested in the confusion matrix still, but I will discuss formally. Then we'll discuss. Then you can understand. So if we don't do any kind of, if we don't delete any outliers, but simply we have a F1 data set, then the accuracy using decision tree, and we are 70% used for training and 30% for testing. The accuracy is 90. This is 95%. 0.95 means this accuracy, that is 95%, right? Just now we are in the same code. We're not using now F1. Now we're going to use F5 because F5 is a data set where what we have all that. So I can delete from here, delete directly. I can use here, no problem. So deleting from here, right? So because we're not going to use F1, that's why this part is omitted from here. Now we are going to use F5 because F5 is a data set where we have the data, the refined data after outliers are removed. So here we have a F5. So here again we have a F5. Simply we're doing, right? Once you can understand, now simply you can do all the tasks very simply. So now the running here. See the accuracy. How much is the accuracy? 0.88. Accuracy is dropped. Accuracy is dropped. So you try to understand that the box plot is applicable for one-dimensional data. So whenever the box plot is used, you find the outliers in case of multi-dimensional data, and in that case, the accuracy actually doesn't improve. The same thing, if I say already we have seen that some kind of outliers can be there. If the outlier is detected using some other detection technique, because we're having different kind of outlier detection technique. For your interest, actually, I'm executing this one. We have another kind of outlier detection technique that is not a single dimensional, there's a multi-dimensional. Again, you see it. Stop the mic, mute the mic. Yeah, madam, somebody is talking. Okay. So now, but we have an idea. We have an idea that I have a number of things here. I'm not going to run all those things, right? After removal, here we have seen this is the accuracy. Now, so we have a general idea that some kind of outliers are there, but exactly those rows would be the outliers. It doesn't guarantee. It is guaranteed based on only one attributes, that these are the rows. These rows can be the outliers. So, but there can be certain kind of outliers. The number of outliers is 4 only, right? So now, if we use certain different kind of outlier detection technique, where if we define the number of outliers which would be deleted, so where it would be deleted only 4 outliers, then we're looking how much the accuracy is improved. So here, one of the famous, the popular outlier detection technique, that is LOF. This is local outlier factors. So we're going to use that one, right? And in the same data set, and going to omit how many, going to, I'm not telling the whole code, right? I'll tell all the codes one by one when we discuss. The discussion is not over. Just I'm showing you this one because outlier part is not discussed yet. When we discuss outlier detections theoretically, then we'll come in the practical, then we'll discuss one by one all the codes. So coming now here, and this is the code here. So initially that I have applied here the LOF technique to find the number of outliers. And I want to confine here the number of outliers, it will be 4 only. That's why contamination, please mute your mic, mute your mic, please. Please, I could understand some of you may not be, no, this part may not be interested, those who are the first year, but those who know machine learning, for them this part is very much interesting because now I'm analyzing the things one by one, right? So here, if I 0.03, this is the percentage. This is contamination, means how much percentage of say samples I will consider as the outliers. So I have defined that is 0.03%. because total number of observation in my data set is having 150. So if I define the contamination rate is 0.03, then it becomes 4.5. So the number of outliers, which is going to be treated as outlier, would be removed. That would be only 4 or 5. So if I omit 4 and 5 outliers, but those outliers not same as the outliers what we found using say box plot, because in box plot we found outliers, those are based on a single attributes, but you try to understand here all attributes are taken into consideration. But here just I limit that one, just we're going to treat only 4 samples as outliers. I can increase the value here, right? But initially I want to keep it only 0.03% so that the number of outliers can be 3 or 4. Fine. So by this one, the outlier can be detected and can be omitted. And that one is again stored in F1. And this F1 is now trained using say decision tree. I have kept the same classifier, same data, same percentage, so that for the comparison, it would become very much easier, so that we can understand similar distribution we have, similar database we have. If we change the technique, how the accuracies are being changed. So coming here now, we're running this one. It will take time, some time, I think, possibly. Looking how much time it's taking. Yeah. So here, it has found like that. I'll discuss all those things later. And finally, it removed how many? 5 outliers. Finally, in the refined data set, we have 145 rows. After deleting the outliers, the accuracy of the decision tree becomes 0.97. Try to understand when we use a box plot, then the accuracy becomes 0.88, drops down. And when there is no treatment of outlier with the same decision tree with same setup, the accuracy was 0.95%. But whenever we apply LOF and we limit that, it should be only 5 items, then the accuracy becomes how much? 0.97. So if we have a right outlier detection technique in the right data set, the accuracy will improve. Now, how all those things can be done? For that one, you must have understanding and intuitions. You have to study a lot. Only then you can understand all those analysis. Now, I'm changing this contamination rate. Here, the contamination was how much? It was a 0.03. If I make it 10%, looking how much? I'm making it 10%, right? 0.1 means what? 0.1 means this is 10%. Now, so 15, we are going to consider the 15 observations as outliers. The observations which are the weak observations, the 15 weak observations are going to be treated as outliers now. Now, just running the code and trying to see how much is the accuracy. See here how many, now the size of the data set is how much? 135. Size of the data set is 135, means how many outliers are there? 15 outliers, because we define the contamination rate, that is 0.1, is 10%. That's why 15 samples are treated as outliers. So if you do, the contamination rate is the increase of 0.1, means 10%, then the accuracy with the same setup of the decision tree becomes how much? 0.9512, right? So again, you try to understand according to your contamination rate, how many should be done. All those things actually, this accuracy varies. So how many should be done, say outliers kind of thing. So you must have understanding on say data visualization. From data visualization, you can understand how many can be outside of the you can say mainstream or outside of the graph actually, like that, and different kind of calculation is there. So here today we have seen that how the outliers can be detected using, not using LOF. LOF we have to discuss mathematically. Big mathematics is there, right? Around 50 minutes to 40 to 50 minutes will be required for that one, because I had today this one, but I did not have time. I didn't get time. That's why I did not discuss. But here we have, you can see here we have all discussions of about LOF, isolation forest. We have all discussion here. We'll do right later. But you have to be able sound means you have to listen carefully, because number of mathematical equation is there. If you miss one of them, then you cannot understand, because it totally depends on the equation and the mathematics, right? So today just we have done the outlier detection using only the box plot. Still outlier detection is not over, because we have a theoretical outlier detection, then we'll do practically using the Python outlier detection. Different kind of techniques are there. We will be discussing next about that. Thank you, everybody. Any questions today? Keep the questions. I am not in a mood to discuss about it, because already we have the discussions 1 hour 45 minutes, right?
Yes, sir.
Thank you, everybody. Thank you, all the participants. Thank you, everybody.
Thank you so much, sir. Thank you so much. Shall I end the session, sir?
Yeah, I am.